Now let's try using the formula to locate and describe the image in a concave lens. So this is example 2 from the tank, chapter 19. It's page 424 in the new edition. A small light 4 centimetres high is placed 25 centimetres in front of a concave lens of 10 centimetre focal length. Alright, as usual I'm going to start with a quick sketch. Now, a concave lens is diverging, so I'm expecting to have a virtual image. Alright, focal length is 10 centimetres, f, 2f, and my object is 25 centimetres. Okay, so first ray goes parallel and comes out diverging from the focal point. Next ray goes towards the focus, which is actually the one on this side of the lens. Second ray goes towards the focus. When it gets to the line, we divert it, we bend it so it comes parallel. Well, they're diverging. If I'm over here, I'm going to look back and see a virtual image where those light rays appear to have come from, which is about here. I'm going to get a much smaller virtual image between the lens and the focal point. Let's try the formulas and double check all that. So, I'm going to be precise about it. The focus is 10 centimetres, but because it's a diverging lens, because it's concave and therefore diverging, it's actually minus 10. The object distance is always positive. The object is 25 centimetres. V I don't know, but I do expect it to be negative. I just make a note so that when I get my answer, I check it. So let's put it into the formula. 1 over f is 1 over u plus 1 over v. 1 over negative 10 is 1 over 25 plus 1 over v. 1 over v is negative 1/10 minus 1 over 25. I'm not going to try and do that in my head. Negative 1/10 minus 1 over 25. Negative 7 on 50. 1 over v is negative 7 on 50. So v must be negative 50 on 7, which is 49 1/7. Whoops. Why are you not doing that for me? Oh, that's why. 50 on 7, which is, which is 7 1/7. Negative 7 1/7 centimetres. Now, this is negative, which means I'm going to have an upright virtual image, which is exactly what I expected from my diagram. So let's work out the size. Magnification is height of image over height of object, which is V over U. Height of the image I don't know. The object height is 4 centimetres from the question. V is negative 7 1/7 and U is 25. So 7 1/7 divided by 25 is 2/7. 2/7. That's the magnification, much smaller. So the height of the image is 2/7 of 4, which is 8/7, or 1 1/7. And to finish off with, let's answer in words. Therefore, the image is, virtual I usually start with. The image is virtual and upright. Because if V had been positive, it would have been real and inverted. Virtual and upright it's 7 1/7 centimetres on the same side of the lens. It's a bit messy. Let me see if I can neaten it up a bit. 7 1/7 centimetres on the same side of the lens. I'm making it messy. I'm just going to leave it. And it's going to be, I've done something wrong here. I've missed a negative sign. Negative. And it's going to be 1 1/7 centimetres high.